Welcome to The Explainer. Today, we're diving into a pretty wild idea, an AI that can translate the style of one image onto another, but here's the kicker. It does it without ever seeing a before and after example. It's a fascinating puzzle, so let's get right into it.
Okay, so imagine you could take a photograph and just ask an AI to completely change its style. Like turning a summer scene into a winter wonderland, or maybe making a photo look like a Monet painting. You'd think that would require a ton of very specific training examples, right? And that's exactly what an AI did right here. It took this sunny picture of Yosemite and transformed it into a snowy landscape. It's it's incredible. But there's a catch, a really big one, that makes this whole thing seem almost impossible. And that is the central mystery we're going to unpack. See, the AI was never trained on paired images. It never saw a picture of this exact spot in the summer and then that same spot again in the winter. So, how in the world did it know what to change? And just as importantly, what to keep the same? Well, usually AIs learn this kind of thing from perfectly matched data. You can think of it like learning a new language with a dictionary where every single word has a direct translation. But getting that perfectly matched data, that is a huge problem in AI. It's often crazy expensive, it takes forever, and sometimes it's just plain impossible to get. Right, so it's really the difference between having a Rosetta Stone, where every phrase is perfectly lined up, and just having two totally separate libraries. One is full of English books and the other is full of French books. And there's absolutely no guide telling you how they relate to each other. And this was the actual problem that the researchers were facing. They didn't have a bunch of photos of the same animal before and after it magically became a zebra. Nope. They just had a folder full of random horse photos and a completely separate folder full of random zebra photos. That's it. As the original researchers pointed out, the problem's actually even harder than it looks. Because what does it even mean to turn one specific horse into a zebra? There's no single right answer, right? And that ambiguity, it forced them to come up with a totally new way to teach an AI how to translate between these two different worlds. So how did they pull it off? Well, the solution, and it is brilliant, wasn't about trying to find some hidden pairs in the data. No, it was about enforcing a really simple but incredibly powerful rule of logic. And get this, the inspiration for this whole thing didn't even come from the world of images. It came from language translation. The core idea is actually surprisingly simple. If you translate something, you should be able to translate it right back. Think about it this way. If you translate "a horse is in the field" to French, and then you translate that French sentence back to English, you should get your original sentence back. If you don't, if you get something weird like "a pony is in the meadow," you know for sure that one of your translators messed up somewhere. That is the core insight right there. In the world of machine learning, this idea has a name. It's called cycle consistency. It's this simple but really profound rule that says if you go from domain A to domain B, and then you come back from B to A, you should end up right where you started. This one single rule is the key that unlocks this entire process, and it's the foundation of a famous algorithm called CycleGAN. So, to make sure this rule is followed, the researchers built this really clever system of competing AIs that basically teach each other how to get better and better at being translators. Okay, so think of it like a team of four. You've got two student artists, those are the generators, and their job is to create forgeries. One tries to paint horses to look like zebras, and the other one paints zebras to look like horses. And then you have two really sharp art critics. Those are the discriminators. And their only job is to look at images and tell if they're real or if they're fakes made by the student. So here's how it works. The whole system is forced to obey that cycle consistency rule. A horse gets translated into a fake zebra by one of the artists, generator G. Then that fake zebra gets translated back into a horse by the other artist, generator F. Now, if that final horse doesn't look almost identical to the original one, the system gets a bad grade. It's penalized. And of course, the rule applies in both directions. A real zebra is turned into a fake horse and then sent right back again. By forcing this round-trip journey for both translations, the AIs have no choice but to learn the essential features of what makes a horse and what makes a zebra without ever being explicitly told. So now for the fun part. Let's look at the absolutely amazing results that this technique, CycleGAN, can produce. Because believe me, it goes way beyond just turning horses into zebras. First up, yes, it can do that classic horse-to-zebra translation. But look closely. It's not just, slapping on a stripe pattern. It's adding those stripes while perfectly preserving the horse's original pose, the lighting, the background, everything. It can also change the entire season of a landscape. It can turn a snowy winter scene into a lush green summer one. And again, notice how it keeps the underlying structure, the mountains, the river, totally intact. And maybe the most impressive thing of all, it can translate a regular photograph into the style of an entire collection of art. It wasn't just trained on one Monet painting. It learned the general patterns of Monet's brushstrokes, his color choices, his use of light, from a whole folder of his work. And it can apply that style to a brand new photo. It's incredible. But, like with any technology, it's not perfect. And being honest about where it breaks down is really the key to understanding what's actually going on under the hood. For example, when the researchers asked it to translate a horse with a rider into a zebra, it failed spectacularly. And why? Well, because the training data was full of wild horses and wild zebras. The AI had never seen a single example of a person riding a zebra, so it had absolutely no idea what to do with the person in the picture. And this really points to its main limitation. This technique works best on changes to color and texture. It really struggles with tasks that require changing the fundamental shape, the geometry of an object. Think trying to turn a dog into a cat. For this to work, the two worlds you're translating between need to have some kind of shared underlying structure. So what's the big takeaway from all this? It's that this simple, logical rule of cycle consistency gives the AI just enough of a clue. It's enough for it to discover these powerful, artistic, and really meaningful translations all on its own, finding these hidden connections between worlds without ever needing a direct map. And this really leaves you with a fascinating question to chew on. This AI learned the language of Monet's style just by looking at a collection of his paintings. It just makes you wonder, what other hidden relationships in the world, in art, in nature, in all kinds of data, could be uncovered by this kind of creative, self-teaching AI?